today's session. Here we'll talk about how we can do data import and export with pandas. Then we'll also talk about basic functions on data frames. We'll also talk about null treatments and duplication handling. So if you look at the whole agenda for this session, it is more towards how do you clean and massage your data and how do you connect your Python framework to the external data sources through which you can import and to which you can export the data sets. So if you look at the libraries in Python, we have like many libraries, but generally the most frequently utilized library are these five libraries. Starting with NumPy. So NumPy library is focused on numerical Python or numerical operations. So you talk about any arithmetical functions, you talk about any trigonometry functions, all those functions are already been residing within the NumPy libraries. So whenever you need to invoke those functions or call those functions, then you have to utilize the NumPy library, which is not the objective of today's session. Today's session we are going to focus on Pandas library. Now Pandas library is predominantly utilized to transform the data, and how that will be done we will discuss in some time. Now next two libraries are Matplotlib and Seaborn. This is the data visualization library of Python, and the last one is scikit-learn. This is the machine learning library of Python. So when you talk about machine learning or you talk about data science, this is the library you will be utilizing very often. Now coming to the data import and export part of pandas. Now this is the various kind of data formats which can be handled by the pandas library. Now coming to XLSX or CSV or SQL, these three are the most frequently utilized data formats. However, we also have JSON, HTML, SAS, DT and SDF. So these are a list of data sets or data formats which can be imported, or in these formats we can also export the data out of pandas. Now in today's session I have taken an example of XLSX file, and you can also do the same thing with a CSV file also, because these are very frequently utilized data formats. And wherever we have a database in place, it can be any kind of data server. So SQL is a most frequently utilized data format over there. Our focus will be in XLSX format right now, because we have the XLSX file, and we will go to the live coding setup to understand how we can utilize an XLSX file, and we can call that file into pandas environment and do the data transformation. Now let me go to the coding platform. Cool. Now firstly when we talk about any library, it can be NumPy, Pandas, Matplotlib, Seaborn, scikit-learn, any library. First step that we need to do is we need to import that library into our uh, coding environment. Now in this case I'm utilizing Jupyter Notebook. So in the Jupyter Notebook, in this coding session, I have to first import the pandas library. If you look at this, I'm importing pandas as PD. PD is the alias or is the name which I am giving to pandas. I can't use pandas word very often, but PD is a short form of that word which can be utilized going further. The next step what I'm trying to do is I'm trying to import a Excel from my local setup. This can be any other setups also. Currently I'm utilizing my local setup. Now if you can see, I'm putting an address. It means basically the folder address where the file is residing. This part is the file name, and this is the file format. So by this complete string, I'm giving the compiler or the I'm giving the compiler the information about where the file is residing, what is the file name, and what is the file format. Now let me execute it. So if you can see, there's an asterisk mark here. Asterisk mark means this specific query is getting executed. The moment the execution is done, you'll see a numerical entry here. Now the numerical entry is a sequence of execution. For example, this is the 58th execution that I have done in this session, right? And when it is in a progress mode, you'll see an asterisk mark here. Now we'll learn about the first function. Now if you see, the function which imported this Excel file is called read underscore Excel. Now read underscore Excel, it can be read underscore CSV, it can be read underscore SQL, depending on the file format that you're trying to import. You have to change this function of like a file importing to pandas, right? Now once the file is imported, let's see this file, let's see this data, right? Now df is the data frame which is holding the data which has been imported from the ecom underscore one file from my local setup. Now let's see how does it look like. So is it looking like a file here? Now if you look at this, this whole thing, this whole setup is your columns. These are all your rows, row 1, row 2, row 3, and row 4. All this, while all these things are here. Now you can see one more additional thing is here, which is like this 0, 1, 2, 3, 4. These were not in my data file initially. Now this is the sequencing, row sequencing, which is otherwise called as indexes, default by default added by pandas compiler. So what happens, you are importing a data which is having these columns, these rows. However, pandas will also assign one more layer of sequencing, or one more layer of, like called as index, which will tell you, okay, now it's 0 index means the first row, 1 index means the second row. Likewise, to each row there will be index assigned. Now if you look at the last bit here, so it is showing that this whole data frame is having 42,654 rows and 21 columns, right? So this is the data frame which we just imported in my local setup. Now we'll talk about a few functions. Now let's talk about head function. Now head function is utilized to see the top 5 rows of a data frame. For example, I just read df.head function. I'm not passing any attributes here. So by default, it will show you the first 5 entries in a data frame. Now I also can put an attribute here. Suppose I say, okay, just show me the top 2 rows. This is the top 2 rows, right? Likewise, you have tail. So tail shows you the bottom 5 rows of your data frame by default. Now, when you put an attribute here, suppose you want to see 3 columns or 4 columns, or oh sorry, 3 columns, 4 columns, or like suppose you want to see 1 row for specifically, or 2 rows specifically, then you can just put 2 or 3 or 4, whatever number you want to, and then if you say df.tail2, it will show you the last 2 rows or the bottom 2 rows of the whole data frame. Now this is how you basically have an idea about, okay, this is the rows, this is how the rows looks like, this is how the column looks like. Then we come to two very frequently utilized or two very basic functions. First function is info. Now info function gives us a descriptive idea about my data frame. Now if I run this info function, it gives me a lot of information. First information is how many entries are there. Now these many entries are there. Okay, so I can see that, okay, there are 42,654 rows are there in this data frame. So index is starting from 0 and going up to 42,653, obviously n minus 1, because it's starting from 0. Now how many columns I have? I have 21 columns. So these are the column names. These are the not null entries. Now if you can see, total number of rows were 42,654. However, there are 42,653 not null entries, means there is one entry which is null. Likewise, you can also see there are many places the number is lesser than this total number of entries, means these are having few null values, and we'll also see how to handle those null values in the coming codes. And this bit talks about like data type. So basically order id is an object data type, means it's basically a alphanumeric or a alphabetical data type. Now if you look at order date and shipping date, is a date time data type. So basically it's a date variables. Now aging is a float variable, means a numerical variable which can accommodate decimal numbers. Ship mode is object, product category is object, means again alphanumeric or alphabetical. Then sales quantity, sales category, all these things are float, means what? It's basically numerical which can accommodate decimal numbers. Likewise, if you can see in this whole data set, we are having 2 date time variables, 7 float variables, and 12 object variables. Okay, and the memory that it is taking in my system right now is 6.8 plus MBs. Okay, this is what your info function does. Now let's go next to the describe function. So describe function will give you a statistical insights about your data. Now statistical insights means statistics is only possible in numerical entries. Now how many numerical entries you have? If you can see, there are 7 numerical entries here, right? Aging, sales, quantity, sales category, then discount, profit, and shipping cost. So what describe function does is, for this 7 numerical variables, it will show you various statistical uh, elements. First is how many counts are there. Okay, counts means how many not null values are there. What is the average of this? So average aging is 5.3. If I ask you, okay, what is the average discount you are giving to your customers throughout your data set? It is 0.02, means 2%. What is the average profit? So 74.3. So by default, it gives you all those statistical entries count, mean, standard deviation, minimum, percent, various percentiles, maximum, all these things are given through describe. Now, df.columns gives you a list of columns which you have here. Now, if you want to see what is the name of columns I have in my data set, this is df.columns will give you the answer. Now here we'll talk about how do you select specific columns. Okay. Now suppose I have df and I want to select one column. Now this is the one column here. And when I want to select two columns, you'll see a bit of change here. So whenever you want to select more than one column, you have to make sure that you are putting a pair of, a double pair of brackets here. So basically, whenever you are putting one column, you are only putting one pair of bracket. But whenever you are putting or selecting more than one column, for example, I am selecting 4 columns now, then you have to put two brackets, two pair of brackets. This is something to be like remembered well. Now, whenever like in this case, if you are saying I'm selecting a set of columns and I'm assigning to a new data set. Now, df underscore test is a data frame which is carrying a subset of df, and that subset is consisting of all these columns. Now let's see. Now have I let's see this. Now have I selected like 3 columns here? Okay. Now let me just run this df thing again. Okay, I'm just re-importing it, and I'm going down. Okay, and let me run this df test. Now df test should have 5 columns because these are the 5 columns I have selected here. All right. Now, if you look at this, I have selected product category, sales, quantity, and profit. Similar to this, product category, sales, quantity, and profit. Now, I will tell you how to create a new column. So, in this df test, I will be creating a new column called revenue, which is nothing but sales into quantity. Now, let me just say df test revenue equal to df test sales into quantity. Now, look at the df test. Now, do I have a new column created here? If you can see, in the first df we are having column till profit. We have 5 columns, but now I have created a new column called revenue here, and now I am having 6 columns, and revenue is coming at last, right? This is a newly created column. Now this is how you create a column in pandas. All right. Now next thing we'll talk about is how do you drop a column. So in this data set, for example, df test, I want to drop my quantity, or I want to drop my profit rather. Okay. Now I'll be utilizing function called drop, and then you have to assign, you have to tell which column you want to delete. So in this case I will delete profit column, and then you have to mention something called axis equal to 1. Now axis equal to 1, why? Because what happens is in this setup of data frame, your row dimension is called as axis 0, your column dimension is called as axis 1, and your row dimension is a default axis. So the moment you are saying data frame dot drop, it means you are passing a function. So the function should also understand in which dimension it should execute. So in this case, your function should be executed in your axis 1, which is your column dimension. Hence, you need to mention that axis 1 here. Okay. So I'm telling delete profit and delete it from the axis 1 setup. And then lastly, I'm saying in place equal to true. Now, why in place equal to true? So till here, if you execute, you will be executing a temporary function, or it will be temporary execution. It will not be saved. So if you want to save your execution, or if you want to kind of commit your execution, then you need to say in place equal to true. Now look at this. Now when I go and check df underscore test underscore head, are you looking at profit anymore? No, because it has been deleted. It has been deleted, and that deletion has been saved now. So let me just put it here. Okay, great. Now let's look at some other things. So basically, and one more thing here, suppose I want to delete more than one column. So in this case I deleted one column, let me delete more than one column. So I will go I'll say df dot test. I'll say drop, and I want to delete more than one column. In this case, I'll delete suppose product. So product, comma, I'll delete sales. Now, as I told you earlier, it has to be access equal to 1 and in place equal to true. So if you see, when I passed more than one column, I'm actually putting them inside a bracket, because you can't, like when it was only one column, it was fine. But whenever we are going for more than one column, so you have to put it within a bracket. Then only it will be a correct syntax. Now see, I have just deleted two columns here, and have I saved that deletion? Let's check it. Yes. So this is how you delete the columns. Now let's come to a very good function called unique. Now this is a part of your duplication handling. Now when I want to see the unique products or unique entries that I have within one variable, now this is how I get it. So how many unique products I have? These are the unique products I have in my data. So how many product categories I have? This is the product categories I have, right? Now this unique function tells you what are the unique entries or distinct entries that you have in your variable. Now there is something also called n unique. Now n unique is also very similar. That tells you how many, like what is the number of entries, number of unique entries. So unique gives you what are the unique entries, and this n unique gives you what is the number of unique entries. And obviously this will ignore this nan, because nan means null value. So blank entries will be ignored. It will only consider the valid entries. So in this case, electronic, home and furniture and fashion are the valid entries, and these three entries have been considered, and by considering these three entries, the n unique output will come as 3. There is one more variable called one more function called value count. This is also a very vital function. Now what it tells you, it basically will tell you that firstly how many unique entries are there and how many rows are there where these entries are being reported. For example, when I say value count, for product category, it told me, okay, there are 3 unique entries. One is fashion, one is home and furniture, one is electronic. There are 30,775 entries comes reported for fashion, 10,309 entries reported for home and furniture, and likewise 1566 for electronics. Now this tells you the distribution of rows to each of these distinct categories, and this function you can apply very efficiently for other categories also, or other variables also. All right. So drop we have discussed. Now let me kind of tell you one more thing here. Now when I drop few rows, what happens is sometimes I'm having a set of data, out of which I suppose dropped few rows or dropped few columns. Now what happens is the index says basically there are few indexes which will be dropped in between, right? So the whole index gets jumbled up. And the same thing I'll be telling you, like when I'll talk about null handling, I'll talk about this thing more. But again, reset index is a function which is utilized to reset the indexes of the new entries. So for now we'll just skip it. I'll talk about it when I talk about the null handling part. Okay. Now let's talk about conditional selection. In this case, I want to select all the rows where the product category is electronics. Now how I can do that? This is how I can do that. I'll say df means data frame, and in the bracket I'll put a condition. The condition is I'll select all the elements of data frame where the product category is electronics. Now in this case, if you can see, this is the variable I have considered, and wherever it is electronics, all the variables has been like selected. Now what I'll do is I'll just assign this whole operation to one new data frame. Now df underscore elect is the new data frame which I'm creating through executing this conditional statement, which tells that only give the entries which is having the electronic as a product category. Now this is what I have done. Now if you look at the product category unique, you definitely will have only one entry here, because that is how I have submitted my conditions. Now coming to this coming to a query where I'm putting more than one condition. In this case, I want to take a set of data where the product category is electronics and your order priority is critical. Now these are two conditions. I want to take those entries where the product category is electronic and your order priority, which is another variable here in the data set, is critical. Now this is how you do it. So these brackets are very important. This bracket is giving me one condition, this bracket is giving me one condition, and these two conditions are being joined by a AND operator. Okay, now this is how you can utilize and or operators, and these conditions can go beyond 2 3 anything. So it depends on how, what is the business case you have and how efficiently you're utilizing your and or operators. Okay, great. So now in this case, in this line, what I'm doing is I'm selecting, like I'm putting two conditions, same condition I'm putting, but I'm also, I don't want all the columns, I want only a subset of columns. So if you look at the output of data, if you look at the output of this one, I'll just put head. Now see, you have all the columns. So all the columns you have, but again, which are satisfying this condition means you have only electronics and order priority is critical. So if you say only electronics and order priority critical data frames are here. However, you are not selecting a subset of columns. You are selecting all the columns. Now what I'll do is, I will try to go with an extension of a code. Now here if you see, I'm telling which are the columns I need to see here. Okay, suppose I want to see only this set of columns, not all, only this set of columns I want to see. Then I need to kind of tell the compiler, okay, after the conditional statement is here, I need to tell how many columns I would like to see and what are those columns. Now this is how, suppose I will just say it as 1 and see how does it look like. This is where I put a condition and a select and a set of columns I have selected. Now see, this is the things I have selected. Okay, now this is how your conditional operators work, and also if you want to select a specific set of columns for the conditional selection, you can do that. All right, fine. Now let's talk about how do you handle the null values. So firstly, how do you find the null values? Now for finding null values, you use a function called isNull and sum. Now what isNull operator does? IsNull operator will go to each cell of your data set and will tell whether it is null or not null. Now if you run this without sum, you'll see this. See, it is going to each of the cell and telling, okay, if it is blank, it will say true. If it is not blank or is having some value, it will show as false. Now in this case, it is like putting a false or true in each of the shells, right? Now when I put this sum operator, what happens is it combines those true and false entries in a row, in a column level. Now looking at this, I can tell order ID is having one row as blank or one entry as blank. Order data is having 7 entries are blank. So these are the number of blank values I have per column. Now there's an operator called drop NA. Now drop NA is an operator which is utilized to delete the null entries. Okay, delete the null entries. There are two ways you can handle the null entries. One way is you delete the complete row or you delete the row which is having a null value, or you replace the null value with some value that will be operated with a fill NA operator. I'll talk about that in some time. Now, so firstly, I'll say data null. I'm creating a new data set where data null equal to data null 1 is a new data set where df.drop NA how equal to any. Now it means what happens here is it basically drops all the rows wherever you have at least one null value. Now just imagine you're having 5 columns. Out of the 5 columns, one out of the five column, one column is reporting a null value in 10th row. Now just because that one column is blank, the whole 10th row will be deleted because that is how the operation works. When you say how equal to any means, even if at least one column is reporting a null entry, it means the whole row will be deleted. Even if there are 1,000 columns and out of this one column is null, means the whole row will be deleted. Okay. Second way of this drop NA is you only delete, one second. Okay. Second way is you only delete those rows where how equal to all means where you have all the rows as null, then only delete it. So let's see this. So now in this second way, what I'm doing is I'm deleting only those rows where all the columns are reporting a blank entry or null entry. For example, there is a 10th row where I'm having 10 columns in total, and all the 10 columns are reporting a blank entry. That specific row will be deleted when you say how equal to all. Means how equal to all means delete that row when all the columns are reporting blank or reporting null. How equal to any means delete that row when at least one column is reporting blank. Okay, so likewise, this how operator is a very useful one to be utilized. So depending on your business case, you have to utilize the how operator. All right, now there is something called trace. Now drop n is having something called trace. Now let me just make it a smaller. Let me, 1 second. Fine. Now what does trace does? So basically, trace means threshold. So threshold says that okay, if you are in a 10th row, now trace means that only keep those rows which are having at least two not null entries. Means suppose I am telling trace equal to 5, then it will only keep those rows which are having at least 5 not null entries. Means suppose I am having 7, suppose I am having 7 variable 7 columns, out of which I will see which are those rows which are at least which have 5 not null entries at least. Those rows will be kept, rest things will be deleted. That is how you control your null deletions with the threshold attribute. Okay, then we come to subset attribute. Now what is subset? Suppose you want to do this drop any operation utilizing how and how all how any, but again you're only concerned about a subset of variables. So I only want to focus on product category and shipping cost. Wherever I'm having, so whenever I have both these variables as null, I'll delete the whole row. It means although I have 10 variables, but my focus is in these two variables. Whenever I have these two variables as null, I'll delete the whole row. In this case, I'll utilize the subset and I'll say how equal to all. This is how I will operate this problem statement. Now when I say subset and like when I only put subset, it will like by default it will take how equal to any. So how equal to any is the default, attribute. So in this case, all the rows where either product category or shipping cost is null or both of them are null will be deleted. Okay. Now this is how you can utilize the drop any operation throughout. Okay. Now let's see what about the fill in. Now suppose I want to go to product category in a variable level, and wherever product category is null, I want to replace that blank entry by something called electronic missing. Just an example. Now here what I'll do is I'll go and say okay, data null. Suppose I'll say df product category fill in a electronics missing. So wherever I find the product category is having a null value, that null value will be replaced by electronic missing. So like you can also put not applicable, data missing, something you can put here just to avoid that null value entries. Okay. Likewise, for a numerical entry, for example, shipping cost. Now, suppose you're having a shipping cost here, and wherever the shipping cost is not available, what you want to do is you want to take a mean or average of all other shipping cost and fill that up. Possible. The same thing you can do with suppose you are having an age variable in some data set and you are finding age is blank and you want to take all other people's age, take an average and put that as a value over there. The similar way you can do it. Okay. Great. Now let's come to the duplication handling part. So okay. Firstly, you have to like in duplication handling that there are two functions majorly that you need to use. One is duplicated function, which will tell you what are the duplicates available, and second is drop duplicates, which will delete the duplicates. Now, when you say data, suppose I'll say df underscore df dot duplicated. Now you can see there is no entry here. It means in my data set right now I don't have any duplicated entries at all. Okay. So what happens when you utilize a duplicated entry? Suppose you are having one row which is repeated 3 times. Now in those kind of situations, what will happen is your second row and third row will come as a duplication. Your first row will not be displayed here. You will only display the second row and third row. Duplication handling. In this case, I'm taking a data set which is having duplicates. Okay, so I have this imported data set. If you can see, In this import, I have utilized read Excel, and also I've utilized a specific tab name. Okay, so because with this attribute of sheet name, you can actually only tell the compiler to read this tab only. Okay, now I will just put it as dot head, so that I only see the 5 columns. Now, how do I check that this is having duplicates or not? So for that, I need to utilize this one. So I'll say data duplicate function. Now look at this. You can see that there are many duplicates available in this data set, 5 duplicates rather. So this is 21st row. So 21st means 22nd row with 21 index. Now if you can see this order ID 32, now look at this. So this is a duplicated entry, means so this is the second entry which came to the data set. The first entry was valid. Now you have considered a second entry as a duplicated entry, and likewise I can see there is a third entry also for the same values, right? So it means there are 3 entries for this data set, or like there are 4 entries. So you can check here. So there are 4 entries in data set here, 3 entries which have been displayed here because those are duplicated, and the first entry is considered as a valid and is not reported as a duplication. So understand it clearly. There are in total 4 repeated entries. The first entry was considered as a valid entry and not reported in the duplicated list. So the second, third, and fourth entries have been reported here. Likewise, you are having one more entry here. If you look at this 1146, this is a second entry for a duplicated set of rows, and likewise again this one is also second entry for duplicated set of rows. Now these 5 rows in my whole data set are a set of duplicated rows which I have. Now what I can do, I can find this thing like with a duplicated function, then I can go out right away and delete those entries. Now to delete those entries, what I can do is, so if order ID is one of my unique keys in my data set, for example, if you're talking about an employee data set, or if you're talking about some other data sets, and if you'll definitely having one ID which is unique, you can utilize that unique ID, and you can just go ahead and utilize that to find your duplicates also. So in this first case, I utilized the whole combination. So I was not looking at only this variable and finding the duplications. I was looking at all the variables, and wherever all the variables were repeated, those things are being reported here. But if I want to look at in a variable level, like okay, in this variable, do I have any duplications? In that case, we'll be utilizing this variable here. Now you can see the again duplicated variables being reported here. Okay, so likewise you can go for a variable level duplication check. Now we'll see how to delete duplicates. Okay, so now what I'm doing here, data drop duplicates is a function utilized to delete duplicates. So subset is none, means when I'm talking about a duplication, I'm talking about the whole row. I'm not talking about a subset of columns. Rather, I'm talking about the combination of all the columns wherever it is being repeated. Keep first means, so when I'm this is giving me an option that okay, if you're having 3 rows or 2 rows as the repeated rows, which one you want to keep, first row or the last row, right? So suppose I have 5 duplicated rows. So when I say keep first means I will keep the first entry and all the other entries will be deleted. Likewise, let's run it. So I'll just make in place equal to true so that my data set is saved. And now when I'll just save this data set under 1 second. Okay. Now let's check the duplicates here. How I can check it? I'll just copy this one. So do I have any duplicates here? No, there is no more duplicates here. Okay, so that is why 1 second. Just allow me a second here. Out the duplicates and all that. Now I'll try to deduplicate my data or drop the duplicates. Now how I can do that? With this drop duplicate function. Now drop duplicate function is having various attributes. Now subset is none means I want to drop duplicates wherever, like the definition of duplicate is not based on any subset of the columns, rather it is based on the all the columns, means wherever all the columns are repeated, I'm taking that as a duplication. Then whenever there are suppose 3 rows which are duplicated. In that case, which one I want to keep? In this case, I'm saying keep equal to first. You can also put keep equal to last. It means when you say keep equal to first means keep the first row and delete the rest of the rows. It can be 5 duplications, then keep the first row and delete rest 4 rows, right? And in place equal to true means you are saving this execution. Now after doing this, if I just check the same entry here, if I just check this duplicate entry, now let's see, am I getting any duplications here? No. Now I have successfully deduplicated my data. Okay. Now one bit which was there initially was duplication handling. We talked about it. Second bit was null handling. We talked about it. We also talked about conditional formatting and conditional selections and subsetting of data. These three are all the things that we talked in this session combiningly contributes to your data massaging and cleansing. So it's a very important session, and please make sure you practice this with various data sets available.